Hello, welcome back. So let's continue the interesting debugging practice, that is identify the privilege mode. The scenario of this debugging practice is to switch from the user mode to the supervisor mode. This window is about instruction window that indicate the assembly instruction, and this is register window. You can see this window indicate that the current privilege mode is the user mode. Another information I want to remind you is the SPP field inside supervisor status register. This supervisor status register is only available when RISC-V core is running in the supervisor mode. This starts with S letter. This error indicates the supervisor mode. The SPP bit field is located in 8th bit position, and this bit dated to 1 if the previous privilege mode was user mode, and this bit can contain the 1 if the previous privilege mode was supervisor mode. Now we are going to run this assembly instruction to see what happened inside in this bit field. For this, we have to navigate the menu of the traceroute debugger to display the supervisor status register. For this, we have to go to the CPU menu and then select parameter. Let me do this again. CPU parameter, and I will go to control the status register. I will click the trap set of information, and as you can see, the supervisor status register, this icon contain the various different bit field. Among them, what you can see is the SPP bit field. This information indicate that the previous privilege mode was user mode. Now, for better understanding, I will modify this value from the user mode to supervisor mode for the better understanding. And then if the SPP is the same, the user, the information, you will not identify that this value is actually changing. So I will change the value of SPP to the supervisor mode. Okay, let me run this instruction to see what's going to happen. The first thing I'm going to do is to run this instruction. Okay, A6 register is updated. Now I will run equal assembly instruction, and if equal assembly instruction is run, RISC-V core do the two tasks at the same time. The first thing is to branch into the exception and trap vector base address. Second, the privilege mode switch. Okay, here we go. 1, 2, 3. I will run this instruction. Please take a look at this. SPP field is updated to user mode, not supervisor mode. Now, the current privilege mode become supervisor mode instead of user mode. For better understanding, let me revert this assembly instruction by using l.undo command. Please take a look at it. Here you go, 1, 2, 3. Now, this option show you the original value of the SPP bit field. I will run this instruction again. Okay, 1, 2, 3. Go. Privilege mode switch it, and the bit field SPP bit field also updated in supervisor status register. This shows you the RISC-V core update, the SPP bit field inside supervisor status register. Now I will perform another interesting debugging, that is to read the value of supervisor status register. As you know, RISC-V architecture define the CSRR instruction, as you can see, to read the value of the CSR register. Now, if we run this instruction, the value of the supervisor status register will be loaded to S1 register. So I will run this instruction again. Please take a look at this. The S1 register is updated to this value. This value comes from the value of supervisor status register. Let me revert again to see what happened. Okay, please take a look at this. I will run again. Please take a look at this. S1 register is updated to this value. This value comes from supervisor status register. By reading the previous privilege mode in the trap handler, then it can perform another interesting task. In this example, if trap handler in the Linux kernel identify that the trap occur as a result of equal assembly instruction, next thing to do is to read the system call number to invoke another system call handler depending on the value of the system call number. And if the trap handler identify that the trap occur in segmentation fault, in this case, the trap handler will terminate the Laravel user process. And if the trap handler in the supervisor mode identify that the previous privilege mode was supervisor mode, this means that an trap occurs in the supervisor mode. In this case, another handler will be called based on value of the SPP bit inside supervisor status register. Every time you look into any of trap handler, you're going to see those kind of routine. Now in this lecture, we got to know about interesting signature, that is SPP bit field inside supervisor status register. If the previous privilege mode was user mode, this bit field is updated to 1. If the previous privilege mode was supervisor mode, it was updated to 1. Please remember this, that interesting and signature.